All right, intermediate algebra students, welcome here. I am out today, so I'm coming at you through a video lesson here for 5-5B. And what we're going to be working on today, working with these polynomials, is we're going to be working with multiplying binomials. All right, so we'll take a look at what that is. We did a little bit of it before we went off for winter break. But we're going to kind of revisit it now. So let's look at your warm-up answers and let's see how these worked out for you. Okay, so this warm-up had a sampling of a little bit of everything that we've done so far in Chapter 5 as we've been working with exponents and these monomials. So problem number 1, what you want to do is separate each one of those out into their individual terms, separated by those multiplication dots. Do any math that you can. The x to the power of 2 doesn't have anything to do with it. The y doesn't have anything to do, so all I'm going to do is stick ones underneath of each of those. So that way they're made into fractions, and we're ready to do the rest of the math. This z to the -3, there is something to do with that. We have to turn it into a fraction, so we're going to get 1 over top of z to the +3. Okay, so that's the only one that really changed. Then after we do that, it's time to put everything together. So if we multiply all of those fractions, we have x2 times y times 1, getting us x2y. And then on the bottom, we have 1 times z to the 3, giving us z to the power of 3 on the bottom. All right, so that takes care of problem number 1. Let's go ahead and take a look at problem number 2. We're going to multiply those two monomials together. So start with your numbers 2 and 5. That's going to get you 10. And then for the x4 and the x9, our rule says to add those exponents. So that's going to make x to the power of 13. Okay, so that's how number 2 is going to work. Number 3, we have 3x to the power of 2 being taken to the 4th power. So our rule says we're going to distribute that power of 4 as you can see there. Okay, so if I go 3 to the power of 4, that's going to get me 81. And then the x to the power of 2 to the power of 4, my rule says to multiply those exponents together, and we get that x to the power of 8. All right, so there's number 3. Number 4, we have a couple of steps to do. First, we got to take care of this power of 4. So we're going to distribute that power of 4 into this 2x5y6. All right, so if we do that, 2 to the power of 4 is going to get us this 16 here. X5 to the power of 4 is going to create x20. And y6 to the power of 4 is going to create y24 because our rule says multiply those powers. Now that we did that, we're going to multiply these two monomials together. Okay, so if we multiply them, the 16 is going to get multiplied by the negative, so that's going to create -16. The x1 times the x20 is going to make x21. And the y2 times the y24 is going to make y26. Okay, so there's number 4. And then number 5, the last one, the most recent one we did, we're multiplying this monomial 3x2 by this polynomial here in parentheses. So we're going to do distributive property following all of our rules that we're going to do. And let's see, I'm going to move this 1 to a different place. There we go. We want that 1 with that x so we can multiply and follow those exponent rules. Check out your answer, see if that matches what you got. The coefficients, the numbers in front got multiplied, like the 3 times the 5 gave us the 15. The x2 times the x2 is going to create x4. So take a look at the rest of those terms, see if that matched what you got. All right, hopefully that worked out for you, a little review of what we've done. Let's take a look at our skill that we're going to look at today. All right, so we're going to multiply binomials together. So look at problem A. We have this binomial, x plus 5. It's a binomial because it's made up of two terms. And then we have this other binomial, x minus 4. Those are going to get multiplied together. All right, and there's a process we do to multiply those. We talked about it before winter break really quickly before you took that district common assessment, but it's the FOIL process. Okay, and it's a way to distribute and multiply those two binomials together. Okay, so that's what we're going to use. Just a side note, we work with multiplying binomials a lot this semester, and you're also going to work with them a lot if you move on to Algebra 2. Okay, so anyone that's been in Algebra 2 for a bit can probably tell you this is something you work with a lot, these binomials, and the answer we get from when we multiply them. Okay, so let's go ahead and start multiplying these two. Problem A. The first thing I'm going to do is I'm going to put some powers of 1 with those x's to help with the multiplying and the exponent rules. Okay, so the F in FOIL stands for first terms. So we're going to multiply the first one here times the first one there. Okay, the first two terms. So if I multiply x1 times x1, my rule says I need to add those exponents, so it's going to create x to the power of 2. Okay, so there's the F. The O in FOIL stands for outside terms, so we're going to multiply the outside one here times the outside one there. Okay, so we have x times minus 4 is going to create minus 4x. Okay, so there's the O. The I stands for inside in that FOIL acronym. So we're going to multiply the two inside terms. So when I get to this term here, the 5, what I like to do is draw my distributive arcs underneath so that everything doesn't get all mixed up on top. Okay, so I have positive 5 times x is going to create plus 5x. All right, so there's those two multiplied. And then the L stands for the last. So I have the last one on this side, the 5, times the last one on that side, the minus 4, and that's going to create minus 20. All right, so that's what I get when I multiply those two binomials. I end up with a polynomial that's made up of 4 terms. And then there's something we can usually do right here in the middle, and maybe you've noticed it already, but these two are like terms, so we can combine them together. Usually, that middle part we can. So if we do the math, we have minus 4 plus 5. That's going to create positive 1. So our simplified answer is going to be x squared plus just plain x. I mean, you could call it a 1x if you want to, but we usually leave that one off. So that's what I'm going to do. So we have x squared plus x minus 20. Okay, so there's our answer to those two binomials multiplied together. It also creates a unique type of polynomial, which, again, we're going to be working with a lot in this semester. So this particular polynomial has a certain name. It's a trinomial because it's made up of 3 parts. And this power of 2 is going to also give it the name of a quadratic. So it's going to be called a quadratic trinomial because of that power of 2, and because it's made of 3 parts, and it's something we're going to work with quite a bit this semester, and also you work with it a lot in Algebra 2. Okay, so quadratic trinomial is what's created by these binomials being multiplied. Okay, all right, so just a side note there. Let's move on to problem B. I'm going to put some 1s there with those x's because they need some exponents. Now let's go through our FOIL process. We're going to multiply the first one here times the first one here. Multiply those coefficients together, those numbers in front. So that's going to get us 6, and then for the x's, we're going to get x to the power of 2. Okay, so there's the first terms. O, we're going to have outside here times outside here. So we have 2x times positive 2, which is going to get me positive 4x. Okay, so there's the O. I inside is going to be the negative 1 or the minus 1 times the 3x, which is going to get me minus 3x. All right, and then the L, the last, we're going to have minus 1 times positive 2. And that's going to create minus 2 when we multiply those together. Okay, so there's my answer. It has those 4 different terms, those 4 parts. Notice again we can combine those like terms in the middle. So we're going to end up with 6x squared, a plus x again, and a minus 2. All right. That answer, again, making it a quadratic because of that power of 2. That's where that name comes from. And the trinomial because it has those 3 terms. Another way we can multiply these binomials is to actually use what's called the box method. So instead of FOIL, we can set these up into some boxes, and it kind of works like a multiplication chart when we go to multiply these together. Okay, so on the outside, I'm going to put down one of my binomials, x plus 7, and up on top the other one, x plus 3. And now all I need to do is inside of my boxes, I just need to write down the answers I get to these being multiplied. Okay, so in this first box right here, I'm going to have x1 times x1, which is going to create x to the power of 2. Okay, and then in my lower box here, I'm going to have 7 times x, which is going to create positive 7x. Top right, I'm going to have x times positive 3, which is going to create 3x positive. And down in this lower box, we're going to have 3 times 7, which is going to create positive 21. Okay, so there is what you get using the box method. What's kind of nice about the box method is diagonally it sets up your like terms for you. Okay, so we know we're going to have to combine the 7x and the 3x together. So if I combine them, I'm going to get x squared plus 10x plus 21. Okay, so again, we got that quadratic trinomial for an answer. That came about from the box method. You don't have to, it's just another method to use. When we get into future lessons and our polynomials get longer that we're multiplying, sometimes I prefer the box. Other times I just prefer the FOIL method. So it just kind of depends. Let's work out another one with the box method so you can see that again. Some people prefer this just as a way to organize it visually and see what they get. So on the side, I'm going to write 2x plus 1. There's my first binomial. And then up on top, I have 3x minus 7. Okay, I'm going to put some powers of 1s with those x's so I don't forget to multiply those. And then let's just fill in our boxes. So top left box is going to be 2x plus 3x is going to create 6x to the power of 2. Lower left box, I have positive 1 plus 3x is going to create 3x. Top right in my box is going to be 2x times negative 7, or minus 7, so that's going to create minus 14x. And in my lower box here, I have positive 1 times minus 7 is going to create minus 7. All right, I have all the parts of my box filled out. Diagonally, I'm going to combine like terms. It automatically kind of sets those up diagonally. So if we write down our answer and combine those like terms, we get 6x squared minus 11x and then minus 7. All right, so that's how that one would end up working out. You can use whichever method you want. There's just a couple examples using that box method. And then let's take a look at some special cases, a couple unique problems that we have. First, we're going to deal with something called conjugates. These are the same binomial, but they have a different operation. So notice in problem E, we are dealing with an x and a 5. One of them is x minus 5. The other one is x plus 5. So they're identical, just one of them has a different operation than the other. One of them is going to be plus and one of them is minus. And something unique is going to happen. So let's take a look at what we get. I'm going to go through the FOIL process. I'll put some powers of 1 there. So I'm going to take x1 times x1, which is going to create x2. O is going to be outside, so I have x times positive 5, which is going to be plus 5x. On the inside is going to be minus 5 times x, which is minus 5x. And L, the last, is minus 5 times minus 5 times plus 5 is going to get minus 25 for an answer. All right, so there's our four parts, four terms that creates that polynomial. And then notice what's uniquely going to happen because of these conjugates. If you've looked at it, and you probably guessed it, the middle part cancels out. So what we're going to be left with is an x to the power of 2, a minus, and a 25. Okay, so it gets it down to just two parts. It creates a binomial for an answer, and you're always going to have this minus sign between them. It creates a unique type of problem, which we'll talk about later this semester. I don't want to get into it now, but we're going to work with these again in the future, these conjugates. So we're just kind of getting an introduction to them now. Let's take a look at f, and we'll see what we get for this one. So I'm going to put some powers of 1 there. Multiply these together. The first times the first, that's going to get us 36x to the power of 2. All right, then I have 6x times positive 1, which is going to get plus 6x. All right, then I have I, the inside, so the minus 1 times the 6x is going to get minus 6x. And then the L, the last, the minus 1 times the plus 1 is going to create minus 1. All right, so since f is a conjugate problem, these middle terms are going to cancel out. So notice that they cancel each other out. And we're left with a binomial, which is going to be 36x squared minus 1. Notice how it left that minus sign in between the two. And that's what we'd get for problem F. Another perfect case that we're going to look at today are one's called perfect squares. So we have x plus 3 being taken to the power of 2. So what that power of 2 means is you're going to have two x plus 3's being multiplied together. Okay, so it's going to create this. It's going to create x plus 3 times another x plus 3. All right, and it's going to create an answer for us, which is going to be called a perfect square trinomial, and we'll talk about what that means. But let's multiply these two together. So here is what we have, two binomials that are identical. Because of that, power of 2 means we're going to have two of those being multiplied. So let's take a look at what we're going to get. So following our FOIL steps, we have x1 times x1, which is going to create x to the power of 2. We have x times positive 3, which is going to be plus 3x. All right, moving on to our second number here, 3, that we're going to multiply with. We have the I, which is the inside, so plus 3 times x is going to be another plus 3x. And then we have L, the last. So we have positive 3 times positive 3 over here, and that's going to get us positive 9. So that's what we get for an answer to after our FOIL process. The middles are not going to cancel out like our last ones, but we can combine them together. So what we end up with is x squared plus 6x plus 9. All right, so that's what we get for an answer. And as you're observing this, there's some different patterns that you can notice as you multiply these, that on how you ended up with the 6, how you ended up with the 9. I'm not going to point those out to you. I'm going to let you guys explore those and see if you can find some patterns and some shortcuts to producing that answer. But what I do want to talk about is this particular answer is called a perfect square trinomial. It's made up of 3 parts, so there's the trinomial part, and it is a perfect square. Okay, so why is it called a perfect square? So last semester we talked about numbers that are perfect squares. Some examples of numbers that are perfect squares would be 4, 9, and 16 is some of the first perfect squares that we have, and they're called a perfect square because these numbers represent the area of a perfect square. So for example, 9 is the area of a square where the sides are 3 and 3. Okay, 16 is a perfect square because it is the area of a square where the sides are 4 and 4. All right, and if we're looking at this polynomial here, this trinomial, it's considered a perfect square. It has a lot of algebra stuff in there, so it looks funky compared to these guys over here, but it's a perfect square because, let me set this up, if I have a square, which I know it's not exactly square drawn, but if I do have a square, all right, if the area of the square is x squared plus 6x plus 9, that means the sides of the square were x plus 3 and x plus 3. So, okay, so if I had a square where all the sides were x plus 3 and x plus 3, if I multiplied those together, just like we did right here, it would create that answer. All right, so that's called a perfect square trinomial. It's very similar to this here, where we're multiplying two identical sides together to create our perfect square number, but this one is just using algebra expressions. The x plus 3 times the x plus 3 is creating that perfect square answer. All right, and we'll work more with that. We got a project coming up about those perfect squares, but that's where it comes from. That's why it has that name. Let's take a look at h. It's another perfect square because what they're going to have us do is multiply a 2x minus 3 times another 2x minus 3. All right, that power of 2 says you need 2 of them, and we're going to multiply those two together. Okay, so I'm going to put some powers of 1s with those x's, and now let's do our FOIL steps. So we have 2x times 2x is going to create 4x to the power of 2. Outside, I have 2x times minus 3 is going to be minus 6x. Inside, I have minus 3 times 2x is going to be another minus 6x. And then lastly, I have minus 3 times minus 3 is going to be plus 9. All right, so there's my 4 parts. After my FOIL process, the middle, I can combine that together. So that's going to give me 4x squared minus 12x plus 9 as my final answer. Okay, so there would be my perfect square trinomial, the way that that answer came out to be. All right, I think that's all we have to cover in today's notes. I have a couple for you to try. So try this one, number 1, see how that goes. Try number 2, it's a perfect square trinomial, or a perfect square. So see, we have 5x minus 4 to the power of 2. So multiply those together, and you'll end up with a perfect square trinomial is what I was trying to say. So see how that goes. We'll pause the video, and then we'll take a look at your answer here in just a minute. All right, let's take a look and see how these would have worked out for you. So whether you did FOIL or the box method, either way would end up working. I just chose to do the FOIL method. So for my first answer, number 1, the 4 parts I get is a 2x to the power of 2, then a minus 6x plus 5x minus 15. So there's my 4 parts. Combine that middle, and we're going to end up with a minus x there in the middle. Okay, so there would be my quadratic trinomial for an answer to number 1. And then number 2 is going to create a perfect square trinomial as an answer. Okay, so take a look at those steps on what got multiplied together. We combine these like terms in the middle. The 2 minus 20s get you the minus 40. And that's what our perfect square trinomial would end up looking like. All right, hopefully that worked out okay for you. I'll put your assignment up here so you can work on that next. But if you have any questions, I can answer those when you come back. Thanks for watching, and I'll see you guys next time in class.